Live. Okay, so it is 11:13, and our objective really has to do with story problems or applications of rational functions. And again, I keep trying to get you guys to know that the word rational means, what does rational mean? Fraction. Okay, everybody should know that by now. When you see the word rational, you should be thinking fractions, right? Okay. All right. So, Mr. Davies' house needs to be painted. It's true, my cashmere house needs painting. If I hire Saul, the job can be done in 14 days. Because it's probably going to take a few days to go fishing, right? If Saul and Cole work together, the house can be done in 10 days. So then, if I fire Saul, how long would it take Cole to do it by himself, right? So here's how it works, okay? You're going to have the amount of time it takes them to do it together. So we're going to do a fraction, okay? We're going to have Saul's work plus Cole's work equals 1. Because the 1 has to equal 1 because it's one job. We're only going to paint the house once. That's one job. Okay, well, let's just start there. Okay, so Saul's work plus Cole's work has to equal the one job. Okay, now the way we work this is that Saul can do the job in 14 days, right? So he can do his portion in 14 days, plus Cole can do his portion, but we don't know what his portion is, right? If he worked by himself, we don't know what that portion is, right? To get the job done, to get the one job done, right? Now together, so we're adding them together, it'll take them 10 days. So it'll take 10 days plus 10 days, okay? So it's Saul's portion of the work plus Cole's portion of work to get one job done, okay? So far, so good? So I got that started. So the 10 is, because I'm adding them together, this is the two portions together. Okay, now, if I need to solve for x, that's not too bad. Okay, if I want to solve, then I'm going to do first, I'm going to just get a common denominator to make it easy. I'm going to then multiply this by x over x. I'll multiply this one by 14 over 14. Okay, there are several other ways to do this. Yes, John, but I'm just going to do the most basic way, okay? So then I've got a 10x over a 14x plus a 140 over a 14x equals 1. Okay, I just got a common denominator. And I said, okay, well, what does this one have that this doesn't, and vice versa? This fraction needed an x, and this fraction needed 14, so we have a common denominator, 14x. Thumbs up? So, since I have a common denominator, let's just rewrite it with the common denominator. Okay, so, and we'll add, we'll go to, okay, 10x plus my 140 equals my one job. So all I'm doing is solving. I got my common denominator first. I have my common denominator first, and since I have a common denominator, then I can combine it, 10x plus 140. Don't add those because those are different. And now I'm going to solve for x. Well, to solve for x, let's just cross multiply, right? Let's cross multiply and solve. So if I cross multiply and multiply my 14x up here, and I'll multiply my 1 up here, which is kind of silly to multiply by 1, right? Kind of silly to multiply by 1. So if I do this, I get a 10x plus a 140 equals a 14x. So I multiplied the 1 up here, which really doesn't change anything. Multiply the 1 up here, doesn't change anything. And the 14x times 1 is 14x. Okay, now solving is pretty easy, isn't it? So minus 10x minus 10x. I've got 140 equals a 4x, right? Divide by 4, and let's see how slow Cole is, huh? I need to borrow, I need a calculator. Did you get the answer yet?
I got 35.
So he's really slow, isn't he? Huh? 35?
35 days?
Wow, Cole's really slow. I guess we better keep Saul, huh? So if I go 140 divided by 4, I get an answer of about 35 days, okay? Better keep them both, right? That's pretty easy.
You get it done.
I would get it done in 5 days because I just, yeah, and I've painted houses before. I usually get them done in 5 days because I get up early and I work until I get it done, right? Yep. Yeah. Okay, turn the page. Now, example 2. So, what I want to do is this. Mr. Davies took a bike ride this summer in Wenatchee. It was a windy day. So he rode 60 miles into the wind and then turned around and rode 60 miles back with the wind, okay? And the wind really, if you guys ever ride bikes, the wind really changes how you ride. I hate riding in the wind. It is hard work. So he can normally average about 12 miles per hour on his bike without any wind. This day, the round trip took 3.5 hours. How fast was the wind blowing? Okay, now, let's see. This problem's about distance, rate, and time. Okay? So before I go too much, think about this. Most of you drive, right? Not everybody, most of you drive. Easy equation. If you drive 60 miles an hour for 3 hours, 60 miles an hour for 3 hours, how far do you go? 60 miles an hour for 3 hours, how far do you go? 180. Agree? So what you did in your head was you did this formula, okay? Okay, right? So in your head you did we used to call it the dirt formula, but distance is equal to rate times time. And you guys should have seen this many, many times, right? Agree? You know this anyway, intuitively you know this, right? Okay, so then what we have here is we've got a distance and we want to find out time, okay? So we're going to do, so I'm going to set up a little chart, okay? So I'm going to do a little chart on this. And my chart is going to be distance, rate, and time. So I like to do a chart because it makes it a little bit easier. So I'm going to have the route going out, my out route. My out route is with the wind. No, my out route is against the wind. Against, right? It's against the wind. Against. And my back route, I'm going to turn around and come back. My back route is going to be with the wind. That's going to be hallelujah. I can just fly with the wind. It's kind of fun to ride with the wind to your back. You can go fast without a whole lot of effort, okay? So, I know that the round trip took 16 miles, right? So, I'm going to have 16 as my distance, and I'm going to have my rate. Now, my rate is going to be against wind. It's going to be 12 miles an hour minus the wind. Subtract the wind, because the wind's going to slow me down. Does that make sense? And then I'm going to have my rate coming back, and that's going to be my 12 miles plus the wind, okay? Now, what I want to do is find out time. How fast, right? So, I don't know anything about time out or time back, but I know the total time took 3.5 hours. But the time out is, in terms of time, let's take this equation right here. I'm going to highlight this equation. Let's rewrite this equation in terms of time. Okay, so if I solve and rewrite this equation in terms of time, this equation will be t equals distance over rate. Okay, all right, I just solved for t divided by r. Okay, so let's do the same thing here. So this time out is going to be my 16 over my 12 minus w, and this one's going to be my 16 over 12 plus w. Okay, and now I got my total time. Okay, so let's solve for time. So my time out, so I'm going to have really for my bike ride, here's my ride. I'm going to have my time 1 plus time 2 equals 3.5 hours. Okay, that's kind of a hard problem. That's why I'm going through it with you. Okay, so all I'm saying is this: the ride out. This is my ride out. Time 1 might be 2 hours. I don't know. And then my time back might be an hour and a half. I don't know. We're going to solve, right? my time 1, time 2, round trip 3.5 hours. Okay, so far. So this is going to be my time 1. Time going out. Okay, so time 1 is going to be my 16 over 12 minus W. Okay, that's against the wind, plus my time back, which is going to be my 16 over my 12 plus W equals my round trip, 3.5 hours. Okay? Now it's going to get easy. Do you want me to back up so you understand what I did? Okay? Let's back up real quickly, okay? 16 miles out, right? 16 miles out against the wind, right? 16 miles back with the wind, okay? The time, to figure out the time out, the time is just the distance divided by the rate. The time back is just the distance divided by the rate, okay? Here's time out plus time back in for a total of 3.5 hours, okay? Now let's solve it. Well, to solve it, we're going to need a common denominator, okay? So what I'm going to do is multiply this one by 12 plus W over 12 plus W. Common denominator, right? I'm going to multiply this one by a 12 minus W times a 12 minus W. We did this yesterday. And then I'll have a common denominator of my 12 plus W times my 12 minus W. That's my common denominator, right? So I multiplied the first fraction by what this one didn't have. So common denominator, okay? This is what you missed, Isaac, yesterday, okay? So to get a common denominator, multiply this one by a 12 plus W. To get a common denominator, I multiply this one by the 12 minus W. Let me show that again. To get a common denominator, I need to multiply this one by a 12 plus W. To get a common denominator, I multiply this one by a 12 minus W. Okay, so then, you're right. 16 times 12, Isaac, you're ahead of me. I'll go that times that, that times that. What is 12 times 16? I get an answer of 192. 192 plus 16W.
Can you simplify the bottom too?
Yes, I probably will. Yes, yes, yes. You're totally right. Okay. Yep. Plus 192 minus 16W equals 3.5. Okay. I'm going to do that. You're totally right, Isaac. I will. Let's see. The 16W's cancel on top, don't they? Cancel, cancel. So 192 plus 192 is 384. So let's go. This is a 384 over, and let's do what Isaac suggested. I think that's a good idea.
So it's
144
minus
minus W squared. Yeah, totally right. I think that's a great idea. Equals 3.5. Okay, great idea. Now it's getting a little less complicated. Okay, let's cross multiply. Okay, let's cross multiply. So if I cross multiply, I'm going to take and multiply my 144 minus W squared up here and my 1 up here. Okay, so let's see what I get. I got a 384 equals a 3.5 times 144 minus W squared. How am I doing? Okay, so it's just it's not hard. We're just going to need to calculate. So the first thing I'm going to do, I could multiply through, but I'm just going to divide by 3.5 first. Okay, again, I could go that times that times that. But if I divide by 3.5 first, it just makes it easier. You okay if I divide by 3.5 first? So let's divide by 3.5, divide by 3.5, divide by 3.5, and I get an answer of about 109.7. 109.7 equals 144 minus W squared. Okay? Now what? Yes, it gets easy. Minus 144 minus 144. So minus 144 equals a negative. I'm running out of room, but okay. Negative 34.28 equals a negative W squared. But I don't like the negatives. You guys agree? I don't like the negatives. So let's get rid of the negatives. Get rid of the negatives. So get rid of the negatives because I got negative, negative. I can multiply by a negative or divide by a negative. Let's get rid of the negatives, negatives. Now what would I do? Now what am I going to do? Square root, right? Square root, square root. Now normally we'd have two answers, plus or minus. But minus doesn't make any sense because we're talking about wind, right? So we're just going to take the square root of that number. So square root of that answer. And I get an answer of that. Oh, it doesn't like that. Okay, go to it. Okay. Enter. It doesn't like that. Clear. So square root of 34.28. And I get an answer about 5.85 miles per hour. That's not much of a wind, actually. But, you know, maybe I'm just getting old. Yeah.
How did you get 34.28?
Oh, I just subtracted. So right here, okay, Seth?
Wouldn't it be negative 34.3?
I don't know. 109, maybe. If I made a mistake, then good for you for catching Mr. Davies' dumb mistakes. Minus 144. I got a 34.28. I did. And then square root, okay? All right, that's it. Now, here's the good news, bad news, okay? A problem like this is on your test. A problem like Saul and Cole working together. This is like the extra credit. Okay? That's a good extra credit, isn't it?
It's going to be like what your extra credit is.
Just like it, different numbers, different scenario, okay? Isn't that nice to know what you're... Just that kind of problem, yes.